Okay, today, welcome to another tutorial. Just do a math tutorial. Today, I'm actually going to introduce you to you how to know when to use sine, cosine, or tangent. So, sine, cosine, or tangent. I'm going to introduce to you when to use these different trig ratios. Okay, let's say we have this right triangle here, and I have the side. This side. Let's say this side is 13. That's 13. Let me write that a little bit clearer. This side is 13. Let's say this side is x. And let's say this angle here, let's give it a 50 degrees. Okay? Let me get that dot out of there. So this angle here is 50 degrees. Okay? Well, it says find what x is equal to. Okay, well, if we remember from my previous videos, we know that sine is, we can use this this quick method here, SOHCAHTOA, okay? And it says sine is equal to the opposite divided by the hypotenuse, okay? Well, and it says cosine is equal to the what? C over H. Well, C over H would be equal to the adjacent divided by the hypotenuse, okay? SOHCAHTOA. Okay? Well, what does this TOA here actually stand for? It stands for the opposite divided by the adjacent. So tan is equal to the opposite divided by the ADJ, the adjacent. Okay? Well, now that we have our trig ratios down, let's go ahead and see which one applies to this function here. Now, if you remember, we're looking from my angle of my 0 degree angle. So we're looking from angle theta, okay? Now, angle theta is here, where my blue dot is, where my degree is, okay? Wherever your degree is, that's where you're looking from. So my degree is here, so I position myself here, and I see what side is opposite and what side is adjacent. Well, if this is a right triangle, I know this is my right angle here, and that must be my hypotenuse, right? Now, looking here, what side is opposite of this angle here? What side is opposite? Well, this side here must be opposite, because if this can't be opposite, this is adjacent to me. So this is opposite. So that is opposite, and this here is adjacent. Okay, well, given that information, what has the opposite and the adjacent? Well, opposite hypotenuse, so no, sine won't work. Adjacent and hypotenuse, so cosine won't work. Opposite and adjacent, well, ding ding ding, the tangent will work. So this is how I set it up. I say tan of theta degrees is equal to the opposite side divided by the adjacent side. Okay, well, what actually is the opposite and adjacent side, and what is theta? Well, in this case, theta is equal to the angle that we are given here, which is, in this case, is 50 degrees. So tan of 50 degrees is equal to opposite. Well, what is my opposite side? It's 13 divided by my adjacent side. What did I say my adjacent side was? I said my adjacent is x, so x. Okay, perfect. Now, let's look here. We have tan of 50 is equal to 13 over x. We can actually set this up as a proportion here by putting tan over 50 over 1. And if we cross multiply, what do we end up with? Well, we end up with tan of 50 x is equal to 13 times 1 is 13. Well, I want to solve for x, so I need to isolate x. I can isolate x by dividing both sides by tan of 50. Tan of 50, because I can get x by itself, so I can solve for it. Okay, well, these tans of 50 cancel out, and I'm left with x is equal to 13 divided by tan of 50 degrees. Okay, well, now that I know that x is equal to 13 divided by tan of 50, let's evaluate that. Well, 13 divided by tangent of 50 degrees, you can go ahead and plug that into your calculators, and you should end up with 10.9. So x is equal to 10.9. Okay? So we've answered this question by using the trig ratios here. So we have x is equal to 10.9 based on me solving for this side by using the trig ratios. Okay, let's do one more example here. Let's say we have the right triangle like this here, and we're given that this is my right angle, and this must be my hypotenuse, of course. Okay, and we say that let's name some sides here. Let's say that this angle here, let's see something here. Let me change it up a little bit. Let's say that this, let me think of something else that we can actually change this to. Okay, perfect. Well, let's say that this angle here is 29 degrees. Let's say that's 29. Let me write that outside of there. Let's say that that angle is 29 degrees. And let's say the hypotenuse is equal to x. And then this side here is equal to 18. And it says, let's find the value of x. Okay, well, if we remember from our trig functions, let's see, what do we know? Well, we're looking from angle theta. So we're looking from this angle here. So we position ourselves down here. And we want to know what is this here, and then what is this? Well, we already know this is my hypotenuse. X is my hypotenuse because it's across from the right, from the 90-degree angle or the right angle. Okay, so we know that that's my hypotenuse. So whatever trig function I use, it has to include the hypotenuse in it, right? Now, what is this angle here? I mean, this side here. Well, this side is actually, it can't be opposite because opposite is across, right? It's over there. It's on the other side, the opposite side. But adjacent means next to. So this adjacent angle here is, this adjacent angle is adjacent with the side 18. Okay? So what trig function use hypotenuse and adjacent? Well, is sine opposite over hypotenuse? No, that's not what we want. Cosine is adjacent to hypotenuse. Well, ding, ding, ding. That's what I want. So let's go ahead and use that. I can say, so I can say cosine of theta degrees is equal to the what? Well, what is cosine equal to? The adjacent over the hypotenuse. So the adjacent over the hypotenuse. Okay? Perfect. Now, so I can say cosine of theta, which is what? And I told you theta is equal to the degrees that we have here that we're looking from. So theta of 29 degrees is equal to the adjacent. What do we say our adjacent side was? It's this side here. Is equal to the adjacent, which is 18, over our hypotenuse, which is x. Perfect. Now we just saw the same thing up top, where we can set this up as a proportion and cross multiply in order to solve for x here, right? So we'll have cosine of 29 degrees is times x. Cosine of 29 degrees times x is equal to 18. Well, I can divide both sides by cosine of 29 degrees, so I can get x by itself. So cosine of 29 degrees on both sides. These cosine of 29 degrees cancel out, leaving me with x is equal to, this pen is not working. X is equal to 18 divided by cosine of 29 degrees. Well, you can go ahead and use your calculators here and plug that in there. 18 divided by cosine of 29 degrees, and you should come up with 20.6. So x should be equal to 20.6. Okay, so that means that this side here is 20.6. So it's 20.6. Okay, x is equal to 20.6. Now, if you want to find the other side and of the right triangle, you know we could just use Pythagorean's theorem here, which is a squared plus b squared is equal to c squared. Okay, but this question only asks us to find the value of x, which is equal to 20.6. Okay, so here are two examples on how to know when to use the sine ratio, the cosine ratio, or the tangent ratio. All we basically do is we take a look at the triangle and see what's given from this degree angle look from the theta degree angle. We see what's given. Is it the opposite given? Is it the hypotenuse given? Or is it the adjacent given? And whatever is given, whatever two sides are given, we actually make sure we include the one with our side that we want to find. So we need to make sure we include that here. Like in this case here, we found the adjacent in the opposite, so we'd actually use a tangent ratio, okay, because it has adjacent and the opposite, and it includes the side that I want to find, which is x, okay, your adjacent side. All right,